MashaAllah. These are corals. Corals are marine animals. Yes, they are animals. They are covering less than 1% of the ocean floor. And they are supporting 25% of all marine lives and over 4,000 sephers. On top of that, they protect us from hurricane, and they help with tourism, they help with fishers, and climate changing.
Well, wait. Did you know that we've already lost more than 50% of corals over the world? And by the end of 2050, we're going to lose them all. This will not lead to only the ecosystem collapse, but this is going to cost $1 trillion globally, severely impacting more than 100 countries globally, including the UAE. Specialists are fighting for the corals. They're trying to use artificial corals and planting them under the ocean, but this process takes time and requires accuracy and efficiency. This is exactly what we're tackling. QMorjan helps identify optimal spots to achieve the highest coral restoration with limited resources.
So how do we do it? We use satellite images from NASA and ESA. We pass them through a classical computer vision algorithm that uses unsupervised learning to detect the coral reef regions and give us a segmented image. Then we convert that segmented image into a graph. We use quantum annealing to solve that graphical problem to get that optimal repopulation strategy. So going deeper into the classical computer vision model, we use specifically Gaussian mixture model that is a soft clustering technique that uses unsupervised learning and provides us with the segmented image of the clusters. For example, here you can see Abu Dhabi's corals. They're literally 15 minutes away from us. You should go visit, they're really pretty. We get this model output, which is a segmented image of coral reefs, land, deep water, shallow water.
Now let's look at a section of coral reef right outside of the UAE. So again, the computer vision model outputs a highlighted area. So the oranges is the highlighting areas where coral reef can actually grow. And then we generate a graph and pass this to our quantum annealing program. The graph consists of nodes that represents the highlighted pixels, and the edges are the connections between neighboring nodes. So the neighboring nodes are defined as nodes that are, or coral reef positions that are within the breeding range of one another. So the quantum annealing program's output then is highlighted nodes, which represents the optimal planting strategy for artificial reefs such that we can maximally cover this region and revitalize it. The budding reproduction range of coral reef ranges depend on the ocean current and temperature, and through research we decided on a 600-meter range for this simulation, and our program optimizes for this by not placing the coral reefs too close to each other that their breeding ranges overlap, but instead just far enough apart from each other to maximally cover this region with the least amount of resources used.
We've modeled the problem as a set cover problem. So the idea is to have each blue dot connected to a pink dot with the minimum amount of pink dots possible. And for this, we used a QUBO formulation that we can run with quantum annealing. And actually, when the island of coral itself has 600 nodes, so it's very big. So first we have to cluster it into separate clusters, and for small clusters up to 30 nodes, we use a classical exact solver that guarantees the optimal solution. While if it has more than 30 nodes, we can provide a solution with quantum annealing or a classical approximate solver that provides good solution with a limited amount of time. So here is like a brief demo, and we actually run the solution above on a quantum annealer.
Now let's talk about is the problem worth solving. We have a global market value of coral reefs valued at $9 trillion US, and yes, that's a trillion with a T. And MENA region comprises 6% of that, and the UAE, our pilot region, is 0.35% of that. So diving into the core of our product's value, we use satellite images, which enables us with low entry and scalability in any country we want to work in. And we can also provide increased efficiency with all the limited resources that we get. Now, you might be wondering what sets us apart. Our competitors use crowdsourced images, and they're based in niche markets like, for example, Australia. And on top of that, we're not only figuring out where the coral reefs are dying, we're actually going beyond that and trying to solve the problem.
So we're planning in the next 3 to 6 months, to validate the product with the UAE Ministry of Ecology and also implement the real.
Great presentation, actually. I don't have a question, but I highly recommend you speak to Archie Reef, which is a startup at Hub 71. I think you can work together on something. They do the 3D printing of the corals, so all the best.
Thank you so much.
Thank you very much.
For that, I just wanted to
One more.
mention, we have 2 team members who were missing, so we just wanted to mention Dream and Sloan.
Sajud.
Let's clap for them.
3 seconds. There's also an X Prize competition on coral restoration, so you can mix the X Prize quantum application with this one, and you can be billionaires.
Perfect. Thank you so much.
We hope.
Thank you.
Solve the problem first. Thank you.
Good job, guys.
Hello, everyone.